Hello everyone, good afternoon. Dear authors and invited guests, welcome to the technical session 3D. Myself, Saksham Sarraf, and this session will be moderated by me. On the behalf of Global Knowledge and Research Foundation, it's my great pleasure to welcome you all in the International Congress of Information and Communication Technology, ICICT 2023, London, United Kingdom. The 8th version of this conference is being organized in a hybrid mode. The physical event was held in London on 20th and 21st February 2023, and the virtual version are held through Zoom, that, uh, that is today and tomorrow, and on 22nd and 23rd February 2023. We hope you will enjoy the interactive sessions throughout the day. In these sessions, we will have 6 presentations, and each presentation will be given 12 minutes for the presentation and 3 minutes for question and answer. And I'll raise a gentle reminder in 10 minutes. We hope that you all stay connected to us till the closing remarks. And if there any query or any update, you can write it to me in the chat box. So just before starting the session, I'd like to introduce you to our session chairs. Dr. Ignacio Pireto Egido. I'm sorry if I pronounce it wrong. He received his PhD from Rey Juan Carlos University, Spain. His research is based on improving healthcare in rural areas of low resourcing settings through the common use of communication technology. He has published results of journals such as IEEE Communication, magazines, journal on telemedicine and telecare, or telemedicine and e-health. Currently, he works as associate professor at Rey Juan Carlos University and collaborated with the EHAS Foundation, focusing his work on designing, deploying, and evaluating innovative solutions to reduce maternal and infant mortality in rural areas for low-resource countries. And we have Om Prakash Rishi sir. Dr. O.P. Rishi sir is presently working as Director IT, Kota University at University of Kota and Associate Professor in Department of Computer Science and Informatics in University of Kota. Present research interest of Dr. Rishi is intelligent system and IT, case-based reasoning, AI application, cloud computing, and e-governance. He has published 40 research papers in international referred journals and 30 research papers in international conference presiding and received 2 Best Paper Awards. He has also published 8 books. Now, moving forward, we'll start the sessions. First, Raphael, I think he's not here.
I think so. The presenter is not available. The first presentation, Raphael, with the paper title of a novel multi-brand patch antenna based on the modification of a rectangular design. Is there any another co-author? I don't think so. So we look forward to the next presentation. Yes, Saksham.
Sir, he is not here either.
I think so. Look forward to the third one.
Sir, not here either.
I think so. He is available now. No. I think
No,
facing some issues. Otherwise, I see him. No worries. So we can look forward to the first presentation of Mohammad Iman.
So Mohammed Amin, or whatever it's pronounced, I'm sorry if I pronounced this wrong. With the paper of Hospital Information System as a code automation and orchestration. You may start your presentation now.
Thank you, Jubair. I will share my screen. Now it's visible. Okay.
Yeah.
So my name is Mohammed Amin. I'm from Morocco, and I will present my paper is Hospital Information System as a code for automation and orchestration. So now I will begin with the content of this presentation. I will start with the project overview. Then I will move to global technique solution, monitoring architecture, automation pipeline architecture, and I will finish by operation architect. So increasing customer expansion and more competitivity business contexts have placed on business leaders to change the way they set their strategy and run their organization. New requirements to incorporate more information and greater interactivity quickly drive up cost and complexity. So this is why we choose to adopt cloud solution to implement and deploy the full solution. So cloud adoption is the way in which business implementation digital transformation to achieve and then which can be. First one is exceptional user experience, accelerate time to market, because in cloud, we can faster deploy our solution more than traditional solution like the data center. High service quality, because we have the auto scaling service that can be scale up or scale down our solution. Cost flexibility, because we will pay just for that we need. And reachability and flexibility, imagine that in the future we want to increase our business. So if we are in cloud, it's faster and it's easy to modify the solution. But if we are in traditional solution, it's more complex. Number 6 is safety, security, and compliance with regulation, because security in cloud, it's like security in a data center, in the traditional data center. And now the characteristic of the solution. For our solution, we will start with deploy an ecosystem allowing deployment of microservice application, because we will use a microservice technology to deploy the solution. We will not deploy the solution in just one way. We will deploy a microservice for the solution. And for that, we will use Docker or Kubernetes orchestrator. And then we will deploy a toolchain allowing autonomy of provisioning throughout the infra as code. The main target of the solution is to deploy the full solution without any human interactive. This is why we will choose to use infra as a code with Terraform script and Ansible for automation to deploy all the server or all the instance. Then we will deploy AWS fully managed Kubernetes cluster. We choose to deploy solution in AWS cloud provider, because it has the ability for HES for hosted healthcare data, because AWS is now able to host healthcare data. And then we will monitor the full solution with Grafana and Prometheus for the cluster Kubernetes, and we will use some services of AWS to monitor the infrastructure like CloudWatch and CloudTrail. The solution should respect the following points: performance. We need to have a performance system. We need to have a viability of all the business process. For that, we will choose to deploy the solution in 3 viability zone behind the load balancer. And then we will use population. For example, we will use internal user and external user. For internal user, we will make some restriction, and for external user is not able to see all the production data. The external user have only access to dashboard to see and monitor data. He will not able to modify. Continuity of the service. For that, we will have to have some plan for recovery. Monitoring, as I said before, we'll use Prometheus, Kibana, and Elasticsearch. And for security, we will use some firewall and we will use JAMOST to connect to all infra in private subnet. And even we will use an SSO and an Active Directory for authentication. So now I will move on to global technical architecture. For this, as I said, the solution should respect the high availability, scalability, automation with Ansible and Terraform, auditability, monitoring, and logging. For monitoring and logging is the same. We will use the same tools to monitor and logging. This is the global solution. So as you say there, this is the function. So we have an IT admin and we have an external user. For an IT admin, they have access directly to AWS account and they have the choice to deploy in GitHub and modify Terraform script or deploy Terraform script to launch Terraform script. But for external user, they have only access to a dashboard. They don't have access to monitor on to administrator of the solution. This is from internet, and now we have some firewall, and the IT admin should connect first to the firewall, and then from the firewall they will have access to infrastructure in AWS in our network. For AWS, we have VPC, virtual private subnet network. And then we will have GitHub action. So the first one is to launch product. We will have a dashboard to launch products. Then we have some script and some Lambda function to target via Lambda function. The Lambda function, they will launch GitHub action, and GitHub action in GitHub, we store all Terraform script, Ansible playbook, and Packer script. So all our infrastructure is coded in GitHub. And then we will use an orchestrator as Kubernetes, is an OKS, Kubernetes. Inside Kubernetes, we have some pod, and we will deploy each microservice in one pod. So one pod is one microservice. Now we move to monitoring of the architecture. And now for logging and monitoring, as I said, we will use CloudWatch to monitor the whole infrastructure. Is an AWS service that give us some information about who is using our account and what action he did. And then we will use, say, the Advisor, Grafana, and Prometheus. This is only to monitor the Kubernetes cluster and to monitor all our microservice. And then we will use Grafana. Grafana is a dashboard. Elasticsearch and Prometheus is a database that we will use to store all metric. And Grafana is a dashboard that can able to visualize all these metric in a dashboard. And then we have load balancer, and load balancer will give access to all IT admin. So the IT admin will have access to supervise cluster Kubernetes or pod, or supervise the whole infrastructure. So we have two type of IT admin. One is to monitor the Kubernetes orchestrator, and second is to monitor the full infrastructure in AWS. So for login with AWS CloudWatch service, and then we will AWS CloudWatch Sidecar automatically to put to retrieve log and push them to CloudWatch. Configure the log router via AWS login confirm app. And then activate the when KS detected the existing of AWS login confirm app. So as I said before, we will have two kinds of monitoring. One for EKS cluster, and first one is for AWS infrastructure.
Mohammed Amin.
Yeah.
Can conclude within next 2-3 minutes, please, your work.
Okay. And now is the roadmap of the solution. We will use Terraform scripts. We will use S3 to store all scripts or log, and then we will use DynamoDB to store our data. And this versioning is for GitHub. This is the same. This is the flow for to deploy a microservice. We will have a command change. Then we will have build the Docker image, and then we will push the Docker image in Argo CD. Argo CD is the orchestrator that we will use to manage all our pod. This is steps that we need, and then this is why we use infrastructure as a code and the orchestrator to deploy the full solution. That's it for my solution. Thank you.
So you have done a great job through this research paper.
Okay.
And you have shown here your global architecture of your this cloud structure.
Exactly.
Yeah. Okay. Can we move on that slide where you display the architecture?
Yeah.
Yeah. Yes. So within this, what are the role of this Terraform script and Packers script?
Terraform script. We will develop Terraform scripts in our GitHub.
Why you have developed this Terraform script? For what purpose you have developed this?
Because we have a different kind of Terraform script. We have script to deploy network. We have script to deploy, for example,
To control the network or control the balance the some component of this network, or what? For what purpose you have developed this?
because we need to have two kind of scripts, because the solution will decouple the solution in a microservice. That's why I used 3 or 4 scripts of Terraform, because if in the future we need to make some modification, so it will be easy to modify only some scripts.
Okay, what this a Packer script will do?
Packer script will just install Ansible dependency.
Okay.
Thank you. And from my side, I have one quick question. It's regarding to choose a cloud solution. Have you considered on study the legal restrictions that you may have in your country to use cloud services that are no locally placed in your country to store health information? In many countries, health information must be stored in countries placed in the server. And I don't know if this is the case in your country and if you have considered that.
I considered that, but I want to have a global solution for an international level. That's why I use the AWS solution, cloud provider. And from my country, yeah, as you said, it's difficult to store the healthcare data in AWS in the cloud. So for my country, I will separate. I will store the critical data, the critical data in one premise server, for example, in some one premise server, and I will use the cloud only for global for the global solution. For the metadata and for the treatment of data, I will use one premise storage solution.
Okay, thank you.
Thank you.
Thank you for your presentation. Now, I'd like to invite Rafael B. Menzer present his paper on the novel built band pack antenna based on modification of a rectangular design. You may start your presentation.
Okay, good afternoon.
Very good afternoon.
The screen is visible?
Yeah.
Okay. First of all, my name is Rafael Mendez. I propose a novel multiband patch antenna based on the modification of the rectangular design. First, we have a summary. We propose a rectangular patch design based in the classic formulas in the design. We started from the patch antenna. This was the first model. This model was served as an initial design to start making modifications to patch geometry with the aim of achieving multiband characteristics. In the figure 1, we can see the first rectangular patch design and the radiation pattern. As we can see, the dimensions are detailed here, the patch and the feed. We can see it's 11 rectangular patch. We have resonance from 2.4 to 11 gigahertz. The modified model, the first modification was made to ground plane. The first size were reduced by half. We can see in the semicircular modified ground plane, and a circumference was placed on it. As we can see here, we have a radius. The radius was from 22.5 millimeters, and we can see the comparison ground versus the modified. We can see we can have more resonance frequencies. Next, we have the modified model. In addition, we have 4 upper clouds were placed. We can see a key space 2 and WLP 1 and 2. They have similar symmetries and show in the figure here, and the next geometry dimensions: the patch, upper twists, feet, and the slots. Now we have a comparison in the normal and the modified. As we can see, the modified have more resonance frequencies from 2.4 gigahertz to 10 gigahertz. We can see the peak size in the red in the figure. The antenna manufacturing was made by a laser design, and we can see the top part. The dimensions was very close to $1 American. Next, we have the results. We use HFSS to simulate the antenna parameters, and we use a noise closed ambient with linear measure. We can see the results are very close to the simulated. We have the radiation patterns. The simulated radiation patterns was very close to the simulated results, as close to the radiation patterns. That's all.
Yeah. Really very nice work, which is you have taken. How close you are with your simulation results?
We have very close to 93.7%. we can see here
How much
the
in
radiation
percentage?
patterns.
How much in
93.
percentage?
Yes. This was a very close, noise-free ambience.
Okay. Yeah, Professor.
Thank you, Rafael, for your presentation. It's very interesting. And do you have plans to keep improving this antenna, or to even produce it for a specific purpose? What do you think it could be useful for?
This we can use for multi-resonant antennas. Maybe we can try some Wi-Fi 2.4 and 5.1. The next step is to minimize to the maybe 5 cents American cents is the next step to the antenna.
Okay, thank you.
Any more questions, Professor?
No, thank you, Saksha. We move forward.
Thank you.
Okay, thank you for your presentation, Rafael. Now, I'd like to invite Victor Hernandez with his paper on NFTs inside the Twitter discussion. You may start your presentation.
Thank you. Can you see my screen?
Yeah.
Okay. Good afternoon. My name is Victor Hernandez Manrique from the University Tecnológico de Monterrey in Mexico. Through this investigation, we were able to perform a sentiment analysis related to the subject NFT using comments from Twitter, and we are glad to share our results with the community. In this presentation, I am going to provide background on this technology, its current situation, followed by the methodology used for this research and its outcome. Finally, I am going to discuss its related and future work. NFTs, which stands for non-fungible tokens, are unique digital assets created by using blockchain technology. Blockchain technology was conceived as the ultimate collective tool for data protection. It uses an encryption technique that allows every user on the blockchain network to verify and approve of change, making it virtually impossible to be falsified. Times are undeniably changing, and topics such as metaverse and NFTs are gaining terrain among the society. This has a great implication in all areas for institutions, artists, buyers, and investors, because they are the ones that are more affected or benefited by this technology. The main idea behind the revolution of NFTs is the ownership of a digital matter, such as a picture, video, etc. The buyer has the legal right to sell it, but this does not exclude other users to download or obtain for personal or business use. The usage of Twitter API allowed us to recover hundreds of tweets to study. These tweets were processed in order to eliminate special characters, hashtags, links, or mentions that were not adding valuable information to the main core of the message. A variety of libraries were used in this investigation. TweetPy was used for accessing Twitter API. Textblock for the visual representation for the most frequently words, or pandas for data manipulation. Additional libraries such as NumPy or Matplotlib were also added. Based on our research, we were able to determine that the English and Spanish communities were the largest consumers of this technology. So the keywords for this investigation were in those languages. Having recovered over 1,200 tweets, we could determine that the average tweet had 183 characters. This is interesting since the average tweet uses only 28 characters, meaning that the typical user has more information to share when we discuss this topic. The minimum length of the tweet was 0, meaning that most of the words used were hashtags or special characters, and those were filtered previously. The maximum length was 308. As we know, the maximum characters allowed in Twitter is 280 before the new updates, but the usage of one emoji is counted as 2 characters. In the figure 2, we analyzed the most repeated words in those tweets. The work was done using the word cloud library, which helps us with the visualization of the words repeated with higher frequency by remarking them with bright colors. It works by counting how many times certain words were repeating and then counting how many times were appeared in those samples. The users relationate the subject with cryptocurrency, as well as words such as right now or hottest, which lead to understand that the technology is worth discussing on these days. The figures 3 and 4 are informative. Even though our main languages were English and Spanish, we discovered tweets in Dutch or Japanese, for example. Now, the graph of the source is worth mention. We could see that Twitter web app was used the most, but Twitter for iPhone is found after Android. There is a popular belief that the users that have an iPhone are located in a higher economical position than the ones with Android, but those last consumers are expressing themselves more. In the figure 5, we have the polarity and subjectivity. Subjectivity is self-explanatory. If the tweet returns a number closer to 0, it means that it has an objective comment about the technology, and closer to 1 means it encounters more feelings than facts. Polarity is related to the feeling of the tweet. Closer to -1 means a negative feeling, and closer to 1, a positive. Finally, in the figure 6, we could see the implementation of a function that classifies the polarity feeling depending on its score. We could observe that more than 60% of the tweets have a positive feeling, 21 neutral, and less than 10% a negative feeling. The main objective of this research was to present a sentiment analysis related to NFTs in order to determine whether the industry should invest in this subject to enhance the interaction between sellers and consumers. The results obtained offer an important insight on which media do the users spend their time commenting, or which language do they speak, allowing to analyze which community is rare or where they're most focused in the long run. Even though the recent news show that the value of NFTs has dropped over the months, the majority of the public has a positive opinion on this technology. This might be due to the fact that more security features and government stipulations support them. Related work presented a similar approach to our investigation, since the examination of subjectivity and polarity is the base of a sentiment analysis. Another techniques, such as sentiment scores, could be applied to this type of research. Its wide range of results, from 0 to 10 instead of 0 to 1 or -1 to 1, may present more accurate results. The examination of data is valuable for companies since their specialized ads invite users to spend on them. At this moment, the general sentiment is positive, concluding that clients are still buying and selling NFTs. Future work is related to the analysis of the processes behind these products, which will let us to understand how the users feel about the purchase procedure to buy them, for instance. Other sentiment analysis might be performed to understand specific aspects of the tweets. That's all for my part. Thank you for your attention.
Thank you, Victor. You have done a remarkable work through your research. First of all, I want to know which algo you use for this analysis.
Which algorithm do you say?
Which algorithm you have used?
With a bit of Python code.
Okay. Why not lexical analysis?
Because we were focusing only on the feelings about those tweets that were commenting about the topic. So we were trying to be more specific about what we were searching for.
Okay, for that, can we use stemming?
Can you repeat the question?
Can we use stemming algorithm for that?
Yeah, I think we can.
You can. So what is the difference? How much difference in the results with these two algorithms? Have you performed any analysis?
No, we haven't performed a comparative analysis between those algorithms.
Okay, thank you. Okay, Professor.
Thank you for your presentation. It's quite interesting. Can you please go back to the slide where you present the polarity and results?
Yes.
Yes, thank you. And here you can base it on the polarity axis. You can say, have you analyzed the specific axis, and can you say something regarding the polarity in this topic?
Well, as we mentioned, we could conclude that the tweets related to the polarities aspect were pointing toward a positive feeling.
Okay, and but then it's there is no too much polarity regarding this the use of NFTs. That's the conclusion, that most of the majority has a positive sentiments. There is not too much confrontation or polarization on this topic.
Yes,
that is it.
Yes, they are directing more to a positive feeling to take advantage of this technology in the future. Yeah.
And have you considered the evolution on time of the tweets? Because you have later shown a graphic of how of the evolution on the of the purchase of NFTs. So have you find any relation between time and this analysis on positive or neutral sentiments?
Well, based on previous researchers, there was like a mixed feeling about the NFTs in the beginning, let's say like 5 years ago, because people assumed that it was going to be the next revolution, but through time, the application of this technology, the blockchain technology, has changed the opinions, because some people think that this technology could be useful, but for others, there's no point of purchasing NFTs.
Okay, thank you.
Thank you.
Any further questions, professors?
Thank you. No more questions. Section, we move on to the next presentation.
Okay, thank you for your presentation. Now I'll invite Luis F. Brenes with this presentation on simple moving average investment strategy during COVID-19 pandemic. You may start your presentation.
Hello, so I'll start sharing the screen now. And I also want to say that I will be presenting our research, but also one of my co-authors, Juan Licon, is here with me, and he will be helping also answering questions at the end. So please feel free to ask the hard questions for Juan, right? So we're investigating about the simple moving average investment strategy during the COVID-19 pandemic. And before we get into the topic and our specific experiment, I want to put you a little bit into context on why we decided to do this. So I would like to start speaking about investment. Usually the more traditional investment strategy, and this is the strategy that most financial experts recommend, it's called buy and hold. This means that you would do, if you want to invest in a company, you would do a research, you would find a good company that has good value, you would buy a stock, and you hold onto the stock for as long as you can. So when it comes to moment to sell the stock, you would sell it because you need money, not as a reaction of what's happening on the market. So you buy a stock, you hold on to it for as long as you can, and you sell it only when you need the money back, not as a reaction of what's happening on the market. As opposed to that, trading has become very popular on the last years. Although a lot of financial experts recommend against trading, it has become very popular, especially on influencers and social media. I don't know if it's the same in other countries, but at least here in Latin America, there are a lot of influencers that present trading as a way to make easy money. There's a phrase that has already almost become a meme here in Latin America that's, hey, you can be rich and you can make easy money using just these two simple cell phone applications, right? So although financial experts recommend against trading, there are a lot of people that say, hey, trading really works, trading can make you rich, right? So what's trading? trading is an attempt to beat the market. You try to identify a trend and then buy low and sell high. So if I guess or I predict that the price will go up next month, I will buy so I get more money. And if I can predict that the price will go down next month, I would sell so I don't lose money, right? Now we wanted to compare these two investment strategies, and we wanted to compare them on the COVID-19 pandemic because it was a period of a lot of economic uncertainty. And these are the two strategies that we compared. When people do trading, we hope they don't use like a crystal ball, right, to try to predict the price of the stocks. They sometimes use mathematical models, and one of the most used mathematical models is called the simple moving average. So when people do trading, that's this dynamic of buying and selling, trying to buy low and sell high, and they use mathematical models, we call that technical trading. So we wanted to compare very specifically buy and hold, that as I said, is to buy a good stock and hold on to it for as long as you can, against technical trading, and in this specific case, the simple moving average indicator. So in the next slide, I put this graph that explains a little bit how the simple moving average works. So here in the blue line, you can see here is the real price of a stock. In this example, it's KHC. And the SMA is the yellow line that is trying to identify a trend. So the red arrows is basically the SMA telling you, hey, the price is going to go down, you should sell at this point. And the green arrows is the simple moving average telling you, hey, I'm identifying a trend that the price is going to go up, so you should buy at this point, right? So you're trying to only buy when the price is going to go up and sell when the price is going to go down. So in order to compare these tech against the buy and hold, we performed a little experiment, and I want you to picture this like the COVID-19 pandemic starts on March 2020, and we have two hypothetical investors that decide to invest in the same companies, but using different investment strategies. One of them will use the buy and hold method, and the other one will use the simple moving average. So we ran a backtesting simulation on Python from March 2020 to March 2022, that were the 2 years in which the pandemic was more prominent. So the first experiment, or the first simulation, is using the buy and hold method. So in this simulation, we chose a group of companies, and stock is bought at the start of the time period, in this case, March 2020, and then sold at the end, in this case, March 2022, and we analyze how much returns we get. And then the second simulation is using the simple moving average. So we would buy and sell several times according to the simple moving average until the end of that period. So March 2020 starts, we buy and sell according to the simple moving average indicator until March 2022. And at the end, we compare which one of both strategies give best returns. And we performed this simulation over data from the S&P 500, that's a financial index, and we extracted the data from Yahoo Finance. We selected the 5 best and worst performing companies from the index, and we did so taking into account their performance from the 2 previous years before the start of the simulation. And this is, remember, we're assuming we have 2 hypothetical investors standing on March 2020. So we cannot assume they have information past that date. So they would select the 5 best and worst performing companies from the index based on data before the simulation starts. In this case, we analyze their performance from the 2 previous years, that this would be a time frame from 2018 to 2020. Then, well, we run the simulation using these 2 investment strategies, and these are the results we got. So long story short, the buy and hold outperforms the simple moving average in 9 out of 10 companies, and it's worth noting that the most conservative literature favors buy and hold strategy over technical trading or over trading strategies at all. And this chart states the results we got. Remember, we analyzed the top performing companies and the bottom performing companies. The second column is the name of the company we're analyzing. And then on the last column, we just state if the SMA was able to beat the buy and hold, if it was able to beat the market. And we can see that that is only true in the last company called KHC. And if you pay close attention, the difference is not that big. Like the buy and hold got like a 65% return against the SMA that got a 71% return approximately. Whether in other companies such as EQT, the difference is very, very big. Like the buy and hold method got more than 300% return against the SMA that got only 95, or ECVQ that return against just 13% return from the SMA. And you can see also that even when the buy and hold lost money on one company, the SMA lost more, right? So our results agree with the more conservative literature that states that buy and hold is an overall better strategy. And I want to quote Sherev et al. In a study they published in 2008, when they say, efficient market hypothesis, if the market is efficient and the price is right at any given time, there is no point in trading. I think it's also worth noting that there's lag on moving average, like because the moving average selects an average price or stock price. There's a little bit of lag when identifying this trend. So lag is always present when you're forecasting using moving average. And since the SMA gives equal weight to each price observation, lag time tends to be big. And there are other moving average that manage this better, such as the weighted moving average and the exponential moving average. So would recommend for future work, maybe repeating this experiment using different moving average that manage better the lag time, and this could maybe render better results. Our conclusion is the SMA could not outperform the buy and hold strategy, and we would recommend using the buy and hold strategy in the future if you're planning to invest on an economic period that has similar conditions to the 19 pandemic and you're investing on an index such as the S&P 500. But at the same time, we also want to acknowledge the limitations of this study. And this experiment alone cannot determine if the buy and hold would be better than moving average in every situation. So for future work, we would recommend repeating this experiment, but changing some of the parameters. One good idea would be to repeat the experiment using different moving average, such as the weighted moving average or the exponential moving average. And you can also repeat the experiment using different stock or more volatile stock than the S&P 500, since the S&P 500 are the best 500 companies in the USA, right? So they're usually very stable companies. And it will be also worth it to try and use different time frames and analyzing periods of economic crisis and economic stability. So that will be all from us, and we're open to any questions you may have about our work. Thank you for listening to us and for inviting us to this conference.
Thank you, Luis, for a very wonderful and nice presentation. Very informative presentation you have made. You have used one term, technical trading. What it means?
Technical trading means when you, remember they stated that trading is when you try to forecast the price of the stock. So I want to buy if I can forecast that the price is going up, and I want to sell if I can forecast that the price is going to go down, right? So technical trading is using mathematical models or computation in general to try to predict these changes in the stock price. In this case, we're using the SMA, that's a mathematical model, and since we're using a mathematical model to try to predict the changes in the stocks prices, that's called technical trading.
Okay, so do you think that the data size is very small? Do you not think? You have taken only to compare 10 companies for your study. I think the size of data is very small. for any confirmative results, do you think?
I think we didn't consider that when we did the research. We were thinking about 2 hypothetical investors investing in 10 companies, but I really appreciate the suggestion. I think like if we did this with a very big data set, it will be we could have gotten better or more interesting results.
Thank you. Over to
Thank you.
Professor.
Thank you, Luis, on a very clear presentation and a very interesting job. I have a couple of questions. The first one is, when you are applying SMA, I understand that you are updating at some point the information you have. So for example, if you start in March 2020, you have data from the last 2 previous years in your experiment, but you consider that after 6 months you already have new data to analyze or to try to foresee the price of the stocks, or how do you use the timeline to update the information you have?
Yes, so well, I think maybe Juan can explain a little bit how the SMA works better. So if I get lost, please Juan come in. But we only use the. Sorry. So we only use data from the 2 previous years to select the companies, but then the way the SMA works is you take a time frame. So I take, like, for example, if my window length are 10 days, the SMA would analyze the price of 10 days, the average price of 10 days. And then for the next day, well, I will add 1 day and I will drop the oldest date. So I will have again 10 days, and then I will take a new day, I will drop the last day, I will have 10 days again. So calculating the average always of 10 days, 10 days, 10 days, 10 days, I identify a trend. So we're always taking into account new data.
Okay. No, I think it's clear now. And a more like future research question maybe. And have you thought or considered that if a lot of people start to use SMA techniques, they in some point can start to have some undesired effect ones over the other? So if a lot of people uses an algorithm to decide when to sell, they may arrive to the same conclusion at the same day, so sell their stocks and causes or cause change in the stock of prices, in the prices bigger than expected. Or so at some point can be this algorithm something that can have a, let's say, side effect if used by a big amount of investors?
I think that's a question for you.
Okay, can you hear me? Yeah.
Yeah.
Okay. The thing here will be that if that it's really hard that happen, since most of the people are small traders, so the possibility of having this kind of change in the stock price will be really hard. Also, most of the stockbrokers have a little specific amount of traders and commissions that they have per day, and also it depends of specifically in the country. In this case, America. I would say it will be really hard that to happen, but we have seen in the last year with GameStop and other stocks that when a lot of people get together and buy the stocks, the price is possible to change. But by using these kind of indicators, it doesn't mean that the price is going to go up or down. It's just one of many different indicators that you can use to decide if this stock is worth it or not.
Okay, thank you. That's all from my side. Thank you.
Thank you.
Any further questions?
No. Thank you. Section proceed for next paper.
Thank you very much for
The
having us.
next two presenters are not available, I think so. So we can conclude with the closing remarks section.
Yeah, okay. So I sincerely thanks all the authors for their excellence present and contribution in this session, and all the participants for the part of this international conference. We hope you enjoyed the conference. We, on the behalf of the whole team, thank you for your support during this version of the conference and the previous 7th version of the conference. And we'll be happy to have you in the 9th version of the conference in 2024. All the presenters would be getting their digital certificates in 2 or 3 working days. Furthermore, the papers have already been forwarded to the Springer, and the publications will be live in 6 months. So kindly cooperate with the team of ICICT 2023. I also like to thank our session chairs, Dr. O.P. Rishi and Professor Ignacio Prieto-Etigo, for chairing the session. A token of appreciation, the chairs on the behalf of Team ICICT and Global Knowledge Research Foundation and partners. Thank you for your valuable presence.
Thank you.
Thank you, section. Thank you, Chair.
Thank you.
Session. If you have any closing comments on the session, you can.
Yep.
Yes, sir.
I wish to thanks our paper presenter whose presence has been invaluable in making this conference a success. I wish to thanks the team of 8th International Congress on Information and Communication Technology 2023 for organizing this wonderful event and giving me this opportunity to interact with you people. And I also thanks to Professor Ignacio Parito for giving this opportunity to share the ideas with the colleagues. Thank you. Thank you so much.
Thank you, sir. Thank you. I request to all the presenters that you can just turn on your camera for the quick snap. Thank you, Professor Ignacio also. Sir, do you have any comment?
Yes, thank you. I also want to, I also appreciate the invitation from the ICICT team, and it has been an honor to participate in this session. And I also thanks the participants that have shared their works. It has been quite interesting and quite diverse session. And thank you, Dr. Prakash Rishi for sharing your knowledge and your insights on these works. So I'm being very happy to be with you this afternoon. Thank you all.
Thanks a lot. Thanks a lot, Doctor. So we look forward to close this session. Once again, good afternoon, good evening, and good night to all. Thank you.
Thank you.
Thank you. Goodbye.
Goodbye.